railway between Kwinana and Coolionobbing forms part of the main trunk system between Perth and Kalgoorlie, 650 kilometres to the east. This in turn forms part of the main transcontinental trunk system between Perth and Sydney, and could be regarded as the most important railway in Australia, certainly if not in the short term, in the longer term. In the late 1960s, the previous narrow gauge railway, 1067 millimetres, was replaced by a standard gauge railway, 1435 millimetres. This represented a milestone in Western Australian railway history. However, this brought increased tonnages upon the line, axle loads were greater than expected, with the result that the track deteriorated prematurely, and we were faced with the replacement of assets earlier than expected, principally rails and sleepers. The civil engineering branch of Westrail has undertaken a major investigation in depth as to the optimum track structure which should replace the present one. And we have determined that concrete sleepers for the first time will be used in Western Australia on the Western Australian system, and the new 60 kilogram Australian rail will replace the previous 47 kilogram. The work has commenced. Construction is well advanced, and the first section has been completed. Before long, the railway will be completely re-sleepered and re-railed between Kwinana and Coolionobbing, providing the highest standard of railway of any government system in Australia. And this railway will take us well through into the 21st century.
Riding into the 21st century and modern air-conditioned comfort should not make one forget that although methods of railway construction have changed, the basic materials are still the same: sleepers, rail and ballast. Track reconstruction differs to new construction, since you have to take the old line up to put the next line down. This is most evident in the change from timber to concrete sleepers. To undertake a project of this size, Westrail had to streamline the upgrading of the railway into 3 separate areas: the manufacture of concrete sleepers, the production of suitable rail lengths, and thirdly, the construction work itself. Late in 1977, a $17.5 million contract was awarded to John Holland Constructions Proprietary Limited for the manufacture of 1 million pre-stressed concrete sleepers and to quarry 200,000 tonnes of ballast. Concrete sleepers are virtually weatherproof and impervious to termites. They're expected to last for 40 years, twice as long as timber sleepers. Ballast, sleepers and rail. So the third component is rail. Early in 1978, Westrail entered into a $15 million contract with the BHP Company Limited for 48,000 tonnes of 60 kilogram per metre gauge rail. A $1.5 million depot was built at Midland to produce welded rail in lengths of up to 274 metres. The $10.5 million contract for laying 370 kilometres of standard gauge and 220 kilometres of dual gauge track was awarded to Roberts Construction Pacific Proprietary Limited. They're using the sophisticated P811 track renewal machine developed in Europe. The machine was launched in conjunction with the official opening of the Kwinana Coolia Knobbing Rehabilitation Project on May 18, 1979 at Northam by the Premier of Western Australia, Sir Charles Court. The machine is fully automated and removes old rails and sleepers, reshapes ballast and places new sleepers and rails in position in one continuous operation. The sleepers are manufactured at Meckering using 7 lines, each 130 metres long. Each line is 4 sleepers in width and 40 in length, giving a total capacity of 1,120 per day. Special indented wire tendons are laid for pre-stressing using forces up to 40 tonnes. It's this pre-stressing that gives the concrete sleeper the strength to withstand the impact loads and stresses of heavy trains passing at high speed. Each sleeper mould is filled with concrete from a hopper, which is then vibrated and compacted. After each concrete pour, the new sleepers are covered and heat cured, enabling a higher early concrete strength. The following day, the sleepers are demoulded, the tendons de-stressed, and then cut to separate the sleepers prior to inspection by Westrail supervisors. An overhead gantry lifts the sleepers for transfer to the stockpile, where they're held 1 month to attain full design strength before being dispatched to the re-sleepering site. The pre-stressing wires are trimmed and smoothed. One sleeper in 400 is subjected to static load tests to ensure adequate bending strength. In order to handle rail at the new flash butt depot, Westrail's 30-year-old coal gantry crane, which has been idle for many years, was transported to the new site and equipped with electromagnets for its new role, loading in 27.4-metre rail and setting it up for depot operation. Following the path of the rail, the first movement is from the rail wagon to the stockpile, then to the inwards rail bank where it's individually end cleaned. The rail then passes by powered roller to the 23-ton welder. Following positioning in the machine, the aligning and welding is automatically controlled. The optimum welding rate of the machine is 20 welds an hour. The rail is then taken by roller to the stripping machine, which shears off excess weld metal. Leaving the stripper, the rail continues to the polishing station where running surfaces of the rail head are accurately restored. Rail is then inspected for alignment and external defects. Powered rollers take the rail to the load-out gantries. Welds are ultrasonically tested before loading, and those showing defects are returned to the welding machine. The rail fleet was specially designed at Midland workshops to handle the 274-metre lengths of rail, which are anchored to one central wagon within the fleet, thus allowing longitudinal movement of rail while travelling on curved track. On arrival at the site, new rail is offloaded on both sides of the track and carefully placed on its foot at the ends of the existing sleepers. Fastenings holding old rails to timber sleepers are removed prior to track laying. The P811 is propelled into position. Old and new rails are threaded into the appropriate rollers to enable the operation to start. As the machine moves forward, the old rails are lifted to each side of the track. Protruding arms on two fixed wheels pick up the old sleepers, turn them over, and deposits them on a conveyor. The ballast between the sleepers is ploughed out and the sleeper bed levelled and compacted. Simultaneously, new concrete sleepers are placed in position. The new rails are continuously threaded in from the side of the track and correctly located on the sleepers. The concept of the P811 track renewal machine is an entirely new one. Its simplicity, speed and precision are unequalled. It's operated by 5 trained operators in conjunction with an additional 7 men. Leading the P811 are usually 6 wagons, each carrying up to 144 sleepers. The wagons are fitted with side rails to carry a self-propelled, portable-type gantry sleeper trolley. The gantry is able to pick up the 16 concrete sleepers at one time. From the sleeper trolley, one conveyor runs to the working section of the track renewal train, and a second returns old timber sleepers. In cool weather, a rail heater follows close behind the P811. This equipment heats the rail and prepares it for the fastenings to be fitted, clipping rail and sleeper together. All rail is fastened at carefully controlled temperatures to ensure track stability. Selection of a fastening system came to a choice between Pandrol and Fist BTR. In the $7.3 million contract, Fist BTR are producing fastenings for standard gauge sleepers and Pandrol for the up main dual gauge section between Northam and Forestfield, where the track is subject to heavier rail wear. Following placement of clips, the rails are thermit welded into sections as long as 8 kilometres. An electromagnet crane has become part of the track laying equipment. It's used to clean up all sleeper plates, anchors and dog spikes and load them into 2 wagons. This operation is followed by the recovery of the old rail, which is winched into flat-top wagons in lengths of 100 metres. Ballast is brought to the track laying site in wagons designed and built at Midland workshops. Following distribution of the ballast, the track is regulated ready for tamping. Once prepared, the track is given a preliminary tamping, followed by a further shaping, and then completed by a final tamping. Westrail's dual gauge connection through the Avon Valley is regarded as the longest railway of its kind in the world. Its upgrading presented special problems. For replacement of the third rail between Avon and Forestfield, a machine known as a Pettibone Mullican speed swing crane was introduced. The existing third rail of the dual gauge track is jointed track in 27.4 metre lengths. This rail is recovered ahead of the P811 operation using the Pettibone and side loading cantilever cranes. Once the P811 has completed resleepering and renewal of the standard gauge track, the Pettibone, operated by one man, is again placed in position. A rail threader connected to the traversing arm is clamped to the end of the new rail length. As the Pettibone reverses down the track, the The third rail passes through the threader, while the traversing arm positions it on the rail seat of the concrete sleeper. In addition to the contract reconstruction of plain track, 160 turnouts between Kwinana and Coolia Nobbing will be replaced using Westrail resources. Prototype sets of points using the new rail on timber sleepers and fabricated at Westrail's Midland workshops were installed at Coburn and Meckering for testing ahead of the manufacturing program. To replace the remainder of the 160 turnouts, sophisticated Swedish exchanging equipment was selected by Westrail engineers. Operation of the SRS lifting gear is simplicity itself. Hydraulic rams are clamped onto the rail at predetermined intervals. After lifting the combined rail and sleeper sections, lightweight temporary rails are placed underneath the old turnout and a series of bogie trolleys are pulled into position. The set is then lowered, hitched to a locomotive or towing tractor and moved off the site. The new turnout, previously loaded onto similar bogie trolleys, is then pulled into place. Hydraulic rams are lowered to support its weight. Trolleys are pulled free and temporary rails removed. The set is lowered into position on the ballast bed where it's welded into the track, ready for the next train. Midland Workshop pattern and foundry staff showed their expertise with the first complete casting of a double intersection crossing. The 4-ton crossing was cast in 2 reversible pieces and was installed at Meriden, where the narrow gauge crosses the standard gauge. It was claimed to be the first construction of its type in Australia. When completed, the new 500 kilometres of track between Kwinana and Coolia Nobbing will provide smoother and faster travelling conditions for Westrail's freight and passengers. To make sure that this will continue to be so, Westrail is taking part in a continuing study of different track structures on 19 individual 1 kilometre test areas being established in 2 sections, one between Meckering and Cunderdin and the other between Cunderdin and Tannin. This enables various types of sleepers to be compared, including steel, concrete and treated carry. Tests include various ballast depths and hardness, also comparison of different rail sizes. Westrail's part in the project is a 10-year track study where the track will be loaded under normal operating conditions and will be closely monitored for any deterioration. The entire standard gauge railway between Kalgoorlie and Kwinana is kept under constant surveillance. Electronic measuring equipment is used to test the track before each section is opened. Information gathered from a data analyzer as it moves along the track is recorded by an onboard computer and transferred into electronic signals before being printed out on a data sheet. Track irregularities are swiftly discovered and the general track condition recorded with further study. The railway role in moving large tonnages of minerals, grain and manufactured goods will increase as the energy crisis continues. The need for reliability, efficiency and speed is paramount. Success depends on getting the kind of track that will take the loads. When the upgrading is completed, Westrail will have the highest grade of government railway within the Australian continent, a railway that will serve us well into the 21st century.